Radioactivity is the process where an unstable atomic nucleus emits energy. This emission occurs in the form of radiation, facilitating the nucleus's transition to a more stable state. Instability in the nucleus stems from an imbalance between protons and neutrons. This imbalance prompts the atom to release energy, or particles, to achieve stability. In 1896, Henry Becquerel's experiments with uranium salts led to the discovery of radioactivity. Becquerel's work marked the initial recognition of the phenomenon of radioactivity. Marie and Pierre Curie expanded this knowledge by discovering new radioactive elements. Polonium and radium were among the radioactive elements discovered by the Curies. These discoveries revolutionized the understanding of atomic structure and properties. Alpha radiation consists of heavy particles, 2 protons and 2 neutrons. Alpha particles are easily stopped by a sheet of paper. Beta radiation comprises fast-moving electrons, or positrons. Beta particles penetrate paper, but are blocked by thin metal. Radioactive elements decay at a constant, predictable rate. This decay rate is characterized by the element's half-life. Half-life is the time it takes for half of the radioactive material to decay. Each radioactive isotope has a unique half-life value. Carbon-14, for example, has a half-life of 5,730 years. Radiocarbon dating utilizes carbon-14's half-life to determine the age of organic materials. Radiocarbon dating is a technique used to estimate the age of ancient materials. It relies on the known half-life of carbon-14, a radioactive isotope of carbon. Living organisms constantly replenish their carbon-14 supply. Once an organism dies, the carbon-14 begins to decay at a predictable rate. By measuring the remaining carbon-14 inches as sample, scientists can determine its age. Uranium-235 is a key component in nuclear power generation. Nuclear fission splits uranium atoms, releasing substantial energy. This energy heats water, producing steam to drive turbines. The turbines power generators, ultimately creating electricity. High exposure to radiation can cause significant damage to living cells. Radiation disrupts DNA and essential cellular processes. This disruption can lead to mutations within the cells. Cellular mutations increase the risk of cancer and other health problems. Radiation labs employ thick shielding materials, like lead or concrete. Shielding minimizes radiation exposure to personnel. Strict safety protocols are essential in radiation labs. Continuous monitoring protects both personnel and the environment from harmful radiation effects.